So here we need to give some examples on finding the points of discontinuity in functions. So the first example is, suppose it is asked to find all the points of discontinuity, of the greatest integer function defined by f of x equals to bracket of x, where bracket x denotes the greatest integer function. So bracket x denotes the greatest integer less than or equal to x. Greatest integer less than or equal to x. So now first we need to draw the graph of bracket x. So if this is the y-axis, this is the x-axis, then from 0 to 1, this will become like this. And then from 1 to 2, it will be like this. From 1 to 2, it will be 1. And from 0 to 1, it will be 0. And again from 2 to 3, it will be 3. It will be 2. This is 3. And then from 3 to 4, it will be 3 again. And then from -1 to 0, it will be -1. And from -2 to -1, it will be -2. So the greatest integer function is also called as a step function. So now here we can see that the case one we can take. Case one is that if c is not an integer, if c is not an integer, then limit x tends to c f of x, which is equal to limit x tends to c bracket x, that will be equal to it will be equal to f of c, which is equal to bracket of c, which is c. Okay, so it will be equal to the integral part of c. And so if c is not an integer, if c is not an integer, then the function f of x equal to bracket x is continuous at x equal to c. Is continuous at x equal to c. And then case 2 is that if we take that is, if c is an integer, then the left hand limit at x equal to c, that will be limit x tends to c minus f of x, which is equal to limit h tends to 0 bracket c minus h, so slightly less than c, so it will come c minus 1. And similarly the right hand limit at x equal to c, that is limit x tends to c plus f of x, that is equal to limit h tends to 0 bracket of c plus h, that will be equal to c. So now it means that the left hand limit is not same as the right hand limit at x equal to c when c is an integer. So therefore you can see, therefore the left hand limit is not equal to the right hand limit at x equal to c if c is an integer. So if c is an integer, then the limit does not exist at x equal to c. So I will tell, so the limit does not exist at x equal to c. Then bracket, okay, so and bracket of c, that will be equal to c only, which is equal to f of c. So therefore the function is defined at x equal to c, but the limit does not exist. So therefore you can see that the function bracket c, or the function f of x equal to bracket x, is not continuous at x equal to c if c is an integer. So I can say, that the function f of x equal to bracket x is discontinuous for all x belongs to z. It means that for all integral values of x, it is discontinuous, and for non-integers, the function is continuous, or for non-integral points, the function is continuous. So it means that every integral point is a point of discontinuity. So here, therefore, you can say, therefore, every integral point is a point of discontinuity. It's a point of discontinuity of the function f of x equal to bracket x, which is the greatest integer function. So then one more question is asked, that is, the question is that find all the points of discontinuity of the function. Find all the points of discontinuity of the function f defined by f of x equals to x plus 2 if x is less than 1, 0 if x is equal to 1, minus x plus 2 if x is greater than 1. Or sorry, it is x minus 2 if x is greater than 1. So now, therefore, here we can see, therefore, limit x tends to c f of x, that will be equal to f of c for all values of x not equal to 1. So if x is less than 1, then we will use x tends to c x plus c, then that will be equal to c plus 2 only. And if it is greater than 1, if c is greater than 1, then we will use the f of x as x minus 2, then that will be also c minus 2. So for all values of x not equal to 1, limit x tends to c f of x equals to f of c. So I can say, so for all real numbers except 1, the function f is continuous. And then at x equal to 1, we have to check the continuity. So now f of 1, that is equal to 0, that is given, and the left hand limit at x equal to 1, that will be equal to limit x tends to 1 minus f of x. So that will be equal to limit h tends to 0 f of 1 minus h. So that will be so slightly less than 1. So we have to use the function x plus 2. So this will be limit h tends to 0 1 minus h plus 2. Since we have to put x as 1 minus h here. So now if we put h equal to 0, that will come 3. And then the right hand limit at x equal to 1, that will be equal to limit x tends to 1 plus f of x. That will be equal to limit h tends to 0 f of 1 plus h. So that will be equal to limit h tends to 0 1 plus h minus 2 we will write. So if we put h equal to 0 here, this will become 1 minus 2, which is minus 1. So therefore here we can see that the left hand limit is not equal to the right hand limit. So I can say that limit x tends to 1 f of x will be 1 minus, okay, limit x tends to 1 f of x does not exist. But the value of the function exists at x equal to 1. So therefore I will say that therefore the x equal to 1 is the only point of discontinuity. X equal to 1 is the only point of discontinuity of the function f. Since y at x equal to 1, the limit does not exist and f of 1 exists. So hope you have understood the concepts, how to find the points of discontinuity of a function. So thank you.